Hello everyone and welcome back to this course on implementing high availability solutions with Windows Server 2019. We are in the third section of the course in which we are going to talk about failover clustering, as you can see from the section's title. This first video is called Getting Familiar with Failover Clustering Architectures, and we are going to discuss the several architectures or ways to create a failover cluster. Now, first of all, what is a failover cluster? Well, the simplest explanation is that a failover cluster is a technology to bring together two or more servers to host a high availability service. Then, if one of your server or nodes fails, the other one will take over the service. Now, failover clustering, it's a quite complicated concept in itself. But Microsoft, with the release of Windows Server 2019, and actually with the release of Windows Server 2016, has made this process even more complicated with the addition of new architectures that they themselves are sometimes quite difficult to even understand. Here, at first, before we get into the implementation of our failover cluster, I want to talk a bit about the really five major architectural designs that you can now implement today with Windows Server 2019 and failover clustering. We will go through here in this section more or less through most of these different options, and we'll start first with the very first of these options, and that is the traditional cluster. Well, we call this the traditional cluster because way back since the original Wolfpack days, or even in the Octopus clustering, even before that time period, this whole process of taking multiple servers together and attaching them to a single data store, a single block level storage, like a fiber channel or a volume or an iSCSI LAN, is mostly the way in which we've created clusters for a very long period of time. Now, this configuration here kind of steals from our first section, and that is the image with the Hyper-V hosts, and is that they share the same piece of storage. So you won't be using a file share in this case, because the difference is this storage is block level storage. Basically, you will be using an iSCSI LAN. You'll be using like a fiber channel volume that you create there on some separate or remote SAN. This configuration is traditional because up until very recently, this was really the only way in which we configured failover clusters. And indeed, here in this section, this is the only type of configuration that will be working yet at first. So I introduced this first because it's the easiest, then sort of differentiate this original way in which we made failover clusters with some of the newer ways that we now have available. So another way to build a failover cluster is, well, has been around basically since the release of Server 2012 R2. And although you see more or less the same configuration here, we have two different cluster nodes that are attached then to a piece of storage. What's different in this option is that this piece of storage is rather some remote storage. It's not an iSCSI LAN. It's not a fiber channel connection to some remote SAN, so to speak. But it's rather a locally attached SAS device with just a bunch of disks that are concatenated together in that device, which both of these hosts are directly connecting into. You won't be using any sort of networking or fiber channel connectors to connect service to the storage. Rather, it's a more traditionalized SCSI connection that they're to your SAS enclosure. The neat part about this configuration, which you might ask why in the world we use this or do this, is that by having this locally attached storage here is this locally attached JBOD SAS enclosure, we can create a cluster that is very easy to work with. This cluster can be our storage host, meaning the location, the location where we actually serve up the storage that exists there on the JBOD enclosure. it can also be our Hyper-V host as well. One of the biggest issues with this, with the traditional approach, as we'll find out here in just a second, is when you create a cluster that attaches to some piece of remote storage. That cluster cannot also be the cluster of the Hyper-V hosts. So, in situations where you want to reduce your hardware costs, where you want to consolidate together different roles into a single location or a smaller number of pieces of hardware, well, the abilities to concatenate together your storage hosts with your Hyper-V hosts and without having to use the extra complexity of a scale-out file server, this is a really easy and very basic, very low complexity way to do it. Microsoft actually, as I said, introduced this back in 2012 or 2012 R2. And at least initially, there weren't actually a lot of these JBOD enclosures that were available and certified by Microsoft at the same time. So you didn't tend to see too many of these out in the wild, right? There have been, since that period, a few more of these JBOD SAS enclosures now available in the marketplace. And so again, for those low complexity situations, you tend to see more of these out in small and medium businesses, let's say. Now, the configuration is great if you've got a single use situation. Perhaps you've just got a couple of Hyper-V hosts that you want to concatenate together to support some virtual machines. But as you start needing to expand this beyond the low complexity use case, we get to our third option here, and that is a two-tiered environment that involves the use of remote storage. So basically, in this environment, we still have our cluster nodes that they themselves are connected up to separate set of storage servers. These storage servers, in turn, are connected out to some piece of data, and this storage location down at the bottom, as you can see here, basically it can be JBOD SAS, it can be an iSCSI connection, or it can be a fiber channel SAN, or any kind of remote storage that we've previously associated this option with option one. The biggest difference here is that by separating out the storage layer from the compute layer, we actually have the abilities to segregate off the storage that we're connecting to from the other activities that will be consuming and making use of that storage. You can see here that our Hyper-V hosts are set up on the cluster nodes, right? So our storage hosts are separated and connected together through a scale-out file server implementation. This additional complexity here, again, is designed when you have the need to scale past that very simple use case like we talked about in option 2. And in your more larger scale data centers, those that are using, for example, iSCSI or fiber channel, this is a common configuration that you'll see when you're not really concerned too much about the cost. Now, these three contributes the type of clusters that we've been able to see for at least an operating system version later than 2012 R2. Okay, everything you've seen here in is something that you could accomplish back in R2. Now, along with Server 2016 and 2019, of course, adds a new set of features. In fact, two more options that we can work with that are designed to go back to the idea of adding simplicity to the whole single use case. And most often, we're talking about hosting Hyper-V virtual machines. Now, the option 4 here is the first of the two options, what we call a hyper-converged storage spaces direct implementation. In this configuration, we have a set of hosts that they themselves are attached not to a single piece of storage, not to a single disk that exists out on some remote SAN, but rather to a set of local disks. The contents of this local disks are then replicated through an internal process native to the S2D, and the contents are also spread apart so that you have a sense of RAID. A piece of data can exist on multiple different machines at once. Okay, so the idea here with a hyperconverged storage spaces direct cluster is to try to align the whole cluster configuration with some of the types of hardware that we are now seeing out in the marketplace. This hardware tends to reduce some of the complexity that we saw back with option 4 by taking the remote disk and then bringing it local to each cluster node. And bringing it local, we don't have to worry about all the IOPS issues and all the interconnect issues and all the networking routing that's appropriate and necessary in order to actually get access to our storage there on that remote SAN. By having all of our disk local to each machine, we ostensibly get better performance for the virtual machines that we're working with and even the other services that we're working with as well. The idea here is also with the Hyper S2D environment is that our storage hosts can also be our Hyper-V hosts, but we don't actually have the need to use the scale-out file server. And what's majorly different between this configuration and what we saw with the option 2 is that we don't have to purchase a special SAS JBOD enclosure device that may or may not actually be on Microsoft's approved list. Microsoft and with Windows Server 2019 realized that perhaps a better way to approach this problem was in software as opposed to waiting for your hardware vendors to create the appropriate enclosures, right? So the reality here is that if you have the correct kinds of disks in each of your cluster nodes and the correct networks, then you can replicate to each other node. So basically you can replicate all of this configuration to all the nodes, and then Microsoft will take care of all the solution for you from within a software point of view. And in fact, if you'll take a look at many of the different kinds of hardware platforms that exist in the world today, there are a lot of hardware platforms that are hyper-converging storage back with compute. And so depending on what you're purchasing, you may find that the hardware you're looking for, even in low complexity or sometimes in high complexity environments, actually lends itself towards the use of storage spaces direct and the hyper-converged architecture. Now we're not done yet because similar to option 3, there is also option number 5. And option number 5 is an option that leans also on storage spaces direct. That is, what we can call a disaggregated S2D cluster architecture. In a disaggregated S2D cluster architecture, here we have storage spaces direct, and we return back to the idea of separating out the cluster nodes. So our compute nodes from our storage nodes. We have interconnects between those compute nodes and then the cluster nodes down below. Then we separate out the roles, so the actual services themselves exist on the cluster nodes and the storage is served by an scale-out file server, SOFS cluster here in the lower tier, right? So the nodes are attached then to local disks, which are replicated with storage spaces direct. And so if you're familiar now with option 3, option 5 is just simply ripping out the entire remote SAN infrastructure and replacing it here with local disks that are replicated with storage spaces direct. As I mentioned earlier, throughout the course, we'll go through the implementation of more or less all of these options so that you can see really how these options get configured. And an important note here, if you're taking this course to be able to solidify your knowledge, or if this is new to you and you're learning it for the first time, recognize that although you're going to see a lot of attention here to the S2D implementation, much of that has to do with Microsoft's presence priority on this new technology that they've developed. So if your environment has an existing SAN, there's nothing wrong with using those more traditional approaches like option 1 and 3. And these new options here again are mostly designed around this new hyper-converged or converged infrastructure where your storage and your compute layers are the same, are basically lying on the same piece of storage.